In this video, we'll look at whether NaCl is polar or nonpolar. So the first thing we need to do is look at the electronegativity difference between Na and Cl. So here is Na, it's 0.93. In chlorine, Cl, that's over here, 3.16. So the difference, it's greater than 2.0. We can think of bond type as kind of on a continuum, where if it's greater than 2.0, we call it ionic. If it's less, it's 0.5. And then in between, we have polar covalent. Different sources will have slightly different numbers. Often you'll see this as 1.7. The point is, NaCl, it's greater than 2.0, so it's not polar covalent or nonpolar covalent. It's considered an ionic compound. In a way, you can think of that as beyond polar covalent. Since it's ionic, it's not going to share electrons. It's going to transfer electrons from the metal to the nonmetal. That'll look like this. The sodium atom, which has one valence electron, transfers that valence electron to the chlorine, which has 7. When it does that, chlorine now has a full outer shell. It has 8 valence electrons, an octet. The sodium, it lost the electron, and underneath there would be an energy level that's full. Since the sodium lost its electron, it becomes positive. The chlorine, it gained an electron, a negative charge, it becomes negative. The positive and the negative, they're attracted to each other in an ionic bond. When we write the full Lewis structure for this, we put brackets around the chlorine to show that the valence electron from the sodium was transferred to the chlorine. It's not shared like in a covalent bond. So again, because of the difference in electronegativity, sodium chloride is considered an ionic bond. This is Dr. V answering the question whether NaCl, sodium chloride, is polar or nonpolar. It's actually neither. It's ionic, kind of beyond polar. Thanks for watching.